So in this video, we're going to talk about functions and difference of functions. So as you see here, we have the definition for the difference of a function right here. So if you want to take a minute to pause this and write down this definition, I would. We're going to apply this definition to this function here. All right, so let's get started. You could do this in parts, and that's what I'm going to do because it may be helpful. So what I'm going to do is I'm going to look at this first part in this numerator, and I'm going to take that f of x plus h. This is telling me that everywhere in my function that I see x, I'm going to put in x plus h. So let's take this function here. We have 2 times x squared minus x plus 3. And again, everywhere as I see x, let's plug in x plus h, x plus h. And now let's start solving. Well, when I solve this one here, I notice that this parentheses is followed by the square, meaning that the square, you're squaring everything in that parentheses. Okay? So let's do that one first. Now there is a shortcut, but I'm not going to do that for those of you who doesn't know the shortcut or is struggling with this type of math. So, and I'm going to do it in parts. You can do multiple steps at one time if you want, but I'm going to do it in parts. That way it's easier to keep up with. So I'm going to use the full method. I got the first times the first. So the first in each parentheses. So that's x times x. And whenever you multiply like bases, right, we add the powers. Well, this has a power 1 and this has a power 1. So we got 1 plus 1, which is 2. So this is x squared. Now I'm going to do, so I said the full method. So full spells out F-O-I-L. So now we're going to do outers. All right, so now I have x times h. And then let's do I for inners. And it's h times x. And let me just talk to you a little bit about that. So 2 times 3 we know is 6. 3 times 2 is 6. So in multiplication, the order doesn't matter. So x times h is also the same as h times x. So I don't want that to confuse you. I just wrote it that way because that's how it was listed. Now let's do the L, which is last. So it's h times h, which again, when we multiply like bases, we add the powers, and these all have a first degree on it, first power. So that means it's going to be h squared. So let's bring everything else down. And while I'm bringing it down, I notice I have this negative. It's actually a -1, but we don't write the 1 there because it's not simplified form. But I got this negative being multiplied to everything in this parentheses. So it's going to change everything. So let's distribute that -1. So I have negative times that positive. Let me get a different color. There we go. Negative times that positive. So it's a negative. I have this negative times this positive. So it's a negative. And then we're going to bring down that +3. So next, we are going to distribute, or actually, let's clean up. And what I mean clean up, these two here are like terms, and we're adding. So that's like saying you have $1 plus $1. So 1xh plus 1hx is going to be 2. And then we're going to bring everything else down. All right, next, we are going to distribute. So I want to distribute the 2 on this outside of this parentheses to everything inside of it. And this notation means it's multiplying. So 2 times x squared, 2 times 2xh is 4xh, 2 times h squared. And let's bring everything else down. And I'm going to have to scroll down, so let me get more paper here showing. And I'm going to go back to the definition here in just a little bit. So we look at this one here, and we notice that there is nothing else that can be combined together. No more like terms. So this one's done. This is what we got here. So when we go back and look at the definition, we got part of it. And then it says minus the f of x function. So what I'm going to do is rewrite everything. So let's let's do this. So let's rewrite. And I'm going to put this in parentheses. We got 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now, I really didn't have to put it in parentheses because if you notice, there was nothing in front of that going to change it. If there would have been a negative sign in front right here, then we would have changed it. That's why I encouraged parentheses. But in this case here, I'm going to go ahead and drop it. There was nothing that was changing it. It's all going to be divided by h. Now, here's the kicker. When we look at the definition, it says that h cannot equal 0. So if you get 0 in the denominator, you messed up. And the reason why it can't is because anytime there's 0 in the denominator, our function is undefined. When we get to the graphing part, we'll learn why it's undefined, but it's undefined. So, again, if you ever put 0 in the denominator, we know that we messed up. So let's go finish this. All right, so how I know I did this right is that my original function actually cancels out. Oh, and I didn't put it on here. Minus my original function. We're going to put that in parentheses. The original function is 2x squared minus x plus 3. All right. So next, I see in front of that parentheses a negative. So I'm going to apply this -1 to everything inside here. So I'm going to rewrite it. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. So I got negative times positive is negative. Negative times negative is positive. Negative times positive, or negative again, is positive again. All right. Now, I'm going to know that I did this right when I can literally mark out my original function we started with. So what do we have here? Let me change this right quick. Let's get, what do we want? We can do yellow. So x squared, it's a negative 2x squared plus 2x squared. That went away, right? We got positive x and I have a negative x. That went away. I have a positive 3. Oh, and let's see what happened to this 3 here. So we need to go back and look. If I came out with something that wasn't originally there, then we know we did something wrong. So let's go back to the start, and I see what I did. It was originally here a positive 3. So in my notation down here, I wrote a -3, and that should have been positive. So when it didn't cancel out, I was like, oh, I know I did something wrong. So that means negative times positive would have been a negative. And yes, my 3's would have canceled out. So if you don't cancel out the originals, then we know we did something wrong. And now I'm going to just rewrite it. So I got 4xh plus 2h squared minus h all divided by h. So we're doing good. And you don't have to do this next step I'm going to do, but I like to do it this way. I like to go break it down. I got 4xh over h plus 2h squared over h minus h over h. And now I want to reduce. And I see that I can reduce by the h's. H goes into itself one time. Whoops. So it leaves me with 1 in its place. H goes in itself 1 time, but there's 2 h's up here, so it's only going to take away 1 h. Now let's explain this right quick. This goes back to that rule when you divide by like bases, we subtract the powers, and it's always top power minus the bottom power. So I got 2 minus 1 is 1. That's how I got the h in the second term. In the first term, I had h over h. And when I rewrite it, because they're like bases, it's both of them has a power of 1. top power minus bottom power. 1 minus 1 is 0. So we go back to that 0 rule. Anything other than 0 raised to 0 is always 1. And another way to say is h goes into itself 1 times. And then we do the same here. So now I have 4x times 1, all divided by 1, which is just 4x. And then I have a positive 2h times 1 over 1. There you go. Minus h goes into itself 1 time. And there is my final answer using the definition of difference of quotients.